In this video, we're going to see how to write formulas for ionic compounds. Remember, ionic compounds are those with metals and nonmetals, or metals and polyatomic ion. All you do is you write the metal first on the left side, the nonmetal on the right side, put the charges, do a crisscross, then reduce charges, and you have your final answer. So for example, we have potassium oxide. Our metal is potassium. That's K plus 1. We know that from our periodic table. K is in group 1 plus 1. There we go. Oxygen is minus 2, again, from our periodic table. We simply do a crisscross. And when we do that, you actually get K2O1. When you do a crisscross, you get rid of the positive and negatives there. We don't care about that. We just care about how many of these there are. And you don't need to write the one at the end because it's implied. It means we know it's there. Okay? In some cases, you might have to reduce. We'll see some examples of that as we go. If you feel fairly confident in this already because you had some lessons on it and you're just reviewing, you can try all these out yourself and then unpause the video to check your work. If you need a bit of a recap, maybe you can follow along with me. But it's a good idea to try these yourself just to assess yourself and see how you're doing. So magnesium chloride, first of all, we know this is ionic because we have a metal and a nonmetal. Magnesium, I'm just showing you all the work here. Magnesium is plus 2 from our periodic table. Chloride is negative 1. Let's do a crisscross here, and we get MgCl2. We have 2 chloride ions and 1 magnesium. Lithium nitride. Once again, we know this is ionic because we have a metal there. Lithium in the periodic table is plus 1. Nitride, IDE, is minus 3. Crisscross that, and you get Li3N. Iron 2 fluoride. This one is an ionic compound that contains a metal with more than one charge. Luckily, we're told the charge here. That's the beautiful thing about this name. It tells you the charge of iron. So iron is plus 2. That's what the 2 there indicates. Fluoride is negative 1. Crisscross, and you get FeF2. Copper 2 sulfide. Once again, ionic. You have a metal with more than one charge. It's a multivalent metal. We know that because of the Roman numeral. So we have copper plus 2, S minus 2. We crisscross, and we get copper with a 2 here, S2 there. We're able to reduce. Remember, reducing it's like saying if you have 2 over 2, what's the most simplified way to write that? 1 over 1. You have to divide that by 2, divide this by 2. So divide by 2, divide by 2, and you get Cu1S1, but you don't have to write the ones. So this is the reduced form for the copper 2 sulfide. Now, calcium chlorate. So be careful here. When you see something end in ATE or ITE, sometimes there's IDE as well, but you got to be careful. It's usually a polyatomic ion. So what do? Well, first write calcium with this charge over here. Then write the polyatomic ion atoms in brackets. Chlorate is ClO3. And put the charge outside of the brackets at the top there, negative 1. When there's no number, it means 1. And now crisscross. Don't change any of the numbers inside the bracket because then you change the polyatomic ion itself. Do not do that. Crisscross, bring the 1 down here, the 2 outside the bracket there. You get Ca, don't need to write the 1, ClO3, 2. Calcium chlorate. There are 2 chlorate ions and 1 calcium ion. All right, let's try the next one. Sodium carbonate. Sodium is Na plus 1. Ending in ATE, carbonate is a polyatomic ion. That's CO3 and our minus 2. Circle, circle, crisscross, and you get Na2, CO3, 1. When you have a 1 outside the bracket of polyatomic ion, you don't even have to put the bracket. You can just write Na2, CO3, sodium carbonate. Let's do the last example here, ammonium oxide. Ammonium is a polyatomic ion NH4+, so let's put that in brackets, NH4 plus 1. Oxide is 2 minus, or minus 2. circle the 2, circle the 1, bring the 1 down here, the 2 down here, and we have NH4, 2, and then O, ammonium oxide. So in this video, we saw so far how to name ionic compounds, how to write formulas for ionic compounds. We simply had to do the crisscross between the metal and the nonmetal, or the metal and the polyatomic ion, and then reduce if possible. In the next video, we're going to take a look at how to write formulas for covalent compounds from the name.